Hi, today I will be speaking about the scientific study of minerals, also known as mineralogy. I will quickly be going over a few samples of minerals and how to tell them apart, also why mineral identification is so important. As in the previous slide, these are all samples of quartz. As you can see, it is a very pretty crystal. We get taught about it early on, and the reason is because it teaches us not to rely on just how a crystal looks to identify it. For example, here is a sample of fluorite. As you can tell, it looks very similar to quartz crystals. However, there are some major key differences in being able to tell one from the other. Here's the mineral calcite. Also, very similar to quartz. It's hard to tell the difference sometimes. One easy way to identify quartz from fluorite is looking at how the mineral grows. Here you can see quartz tends to be elongated and has these really nice crystal formations. However, fluorite, although the same color here, just as the previous sample of quartz, you can tell that its growth is more cubic. Here is another sample of fluorite, and although different colors, it still has the same cubic growth that you can see in the previous sample. This goes to show that color is not the only way to identify a mineral. So what we do now is refer to Mohs hardness scale. This is probably the easiest way to determine the difference between those three samples: quartz, fluorite, and calcite. Here we can see quartz has a hardness of 7, fluorite has a hardness of 4, while calcite only has a hardness of 3. To tell the difference, we use something such as this glass plate. We get the minerals, see which one can scratch glass, and that will tell us which one is quartz. This is because quartz has a hardness of 7, while glass only has a hardness of 5.5. Then you're left with two samples, a sample of fluorite and calcite. However, you do see that fluorite only has a hardness of 4, while calcite only has a hardness of 3. And since they both can't scratch glass, you don't know how to tell the difference. So you found out which one is quartz because of its hardness, being able to scratch glass, but you're left with fluorite and calcite. This leads you to using acid. Here we have a picture of hydrochloric acid, and what you would do next is drop just a couple drops of acid onto each sample. Fluorite will not react with acid. However, calcite will bubble up and effervesce when acid is dropped on it. After showing you a little bit about mineral identification, I would like to quickly touch on why mineral identification is so important. Here we have a sample of hematite. Hematite is mined all around the world because it is an iron ore. We get most of our iron from this rock. Without being able to easily identify rocks such as hematite, we would not be able to continually mine for resources. Resources that give us things like iron, hematite for example, and there's a long list of other ores and rocks such as bauxite for aluminum or chalcopyrite for copper. We need all these things, and we need to be able to identify which from which to be sure that we're getting the right resources that we need.